The National Educator.
Hello students, my name is teacher Thaddeus Baluka and today I'm teaching chemistry form 4. Our topic of today is reaction rate and reversible reactions, and as the subtopic of reaction rate. Welcome. We'll start by looking at the lesson objective. By the end of the lesson, the learner should be able to explain the effects of pressure and particle size on the rate of reaction. Determine the rate of reaction. Let's start by looking at how pressure affects the rate of reactions. The first important point to note here is that pressure only affects reactions involving gases only. It has no effect on reactions involving solids and liquids. So it is important to note that now when we are talking about the effect of pressure on the rate of reaction, this only applies if the reactions involve gases only. And how does pressure affect the rate of reaction? Increase in pressure will lead to decrease in volume. So therefore, when the volume decreases, the gas particles come closer to one another. The reduction in volume due to increase in pressure will bring the reacting gas particles closer to one another. As the particles come closer to one another, this will increase the chances of successful collisions, and this increases the rate of reaction. So we can conclusively say that increase in pressure will bring the reacting gas particles closer to one another. This leads to more successful collisions, and this leads to this increases the rate of reaction. So let's look at now how does decrease in pressure affect the rate of reaction. And we're going to find that when you increase the pressure, when you decrease the pressure, the volume will increase. When you decrease the pressure, the volume increases. The gas particles will move far apart from each other. And hence there will be fewer number of effective collisions because the particles are far from each other. So there are fewer chances of successful collision, and this decreases the rate of reaction. Let's look at the rate curve, how when you vary the pressure, how you can be able to demonstrate the effect of pressure on rate of reaction using the curve. So you are able to have this curve here. So we're having now that we are plotting, for instance, the total mass or rather volume of product against time. So if the pressure is high, at higher pressure as shown there, the reaction will be faster because the gas particles are able to collide more frequently, and therefore the reaction is faster. When you reduce the pressure, or rather when you have low pressure, the rate of reaction is slower because the particles are far apart, and hence there is fewer chances of effective collisions. And it's important to note the term that we are using here. We are comparing we are comparing variation in pressure. So therefore, when you're comparing that, you have to talk about there is slower rate, not slow. There is faster rate of reaction, not fast. Because you are comparing, you must invoke the second degree of comparison